All right. Today we're finding rules. In the questions they have the word family. Sometimes people get freaked out by the word this family. What does it mean?
A family of parabolas. Family seems like a commitment, and I don't like that.
So this particular family we're looking at is ax squared plus c. All it means is that there's something in common. And the thing that's in common is that the equation looks like this. So, if a parabola goes through a couple of points, it passes through the points, so 2 points that we need for this, 1, 7 and 2, 10. And so we use this specific information to find these numbers that are going to be the A and the C. Alright, so depending on what points the parabola goes, these A and C will be different numbers. Still have the same form, ax squared plus c, but the A and C would be different if these were different. So what we have is 2 points. We can put those points into our equation. So if we use 1, 7, we know that x is 1, y is 7, so we'd say we've got 7 equals a times 1 squared plus c. So 7 equals a plus c. If we use the other point, which is 2 and 10, we know that it's equal to 10, a times 2 squared plus c. So 10 equals 4a plus c. We have 2 equations, 2 unknowns, and we do what technique? Been doing it.
B equals A squared, that one?
No, not that one. 2 equations, 2 unknowns. Substitution we could use. Right, we've got to solve them simultaneously. So substitution's one option. What's another option? Elimination's the other option. So if I put this over here, what can I eliminate? And what do I need to do to eliminate it? This one's got a C here and a C here. So I could eliminate the C by taking away. Oh, mucked up. Alright, if we take away 10 minus 7, 4a minus a, c minus c, nothing, so a is 1. And we know that 7 equals a plus c, so if 7 equals 1 plus c, c would be 6. So the equation that we're looking for of this form that goes through these 2 points is y equals 1x squared plus 6, and normally we're just going to write 1x squared as x squared. Alright, so using that information, the 2 points, and the form that we're looking at in this case, we've now found that the actual equation of the parabola that goes through those points is that one there, x squared plus 6. Right. Alright, so depending on what information we're given is what we use. So let's have a look at another example.
Is this like some sort of flexing session or like this with cracking knuckles? Oh! Gross.
It would be so satisfying
That's
though.
fucking
Honestly.
disgusting. I don't want to do it.
Ellie!
Oh.
Good one, Ellie. You started the trend.
Yeah.
Is that a H?
Where?
Through
Through the point, yeah. That's, should be here. But the bottom of the P got in the way. Still needs this a big space, but there shouldn't be. What can you do? Alright. So, what information have we got?
The turning point
Turning point
and an intercept.
and another point. So, the turning point. What do we know about parabolas with turning points?
It's in the middle.
It's in the middle. What else do we know? What do we know about what the equation looks like?
Oh, it's H. You take K. So plus K.
Plus or minus K?
It's plus K.
Plus K. Right, turning point form. So it says the word turning point was used there. We know it's going to look like this. So if the turning point is 2 and 6, what do I do with those numbers? Just put them straight in, yep. So those two numbers go straight in. So we put them straight in. We've got y equals ax minus 2 squared plus 6. All right, this other point, why have we got this other point? What use is that other point going to be?
Where it is for the X and the Y. For the A.
What is the A? What does the A represent? Dilation, yeah. So we need something. We've got information to tell us the turning point, but we need to something so that we can figure out if there's a dilation. So that's where this other point comes in. So yes, you substitute the X and Y. So if we're using 3 and 3, we go that 3 equals A times 3 minus 2 squared plus 6. 3 minus 2, 1 squared. So 3 would be A plus 6. Yes? So A is? -3. So I'll squeeze that over here. So we've got -3 x minus 2 squared plus 6 for our equation. Alright. Let's us look at one now. We might be given a graph, so let's look at one graph. All right. So what information have we been given here?
The X and Y intercepts.
The x-intercepts and the y-intercepts. All right. So let's look at the x-intercepts first. So what do our x-intercepts relate to? Well, we can get the x value of the turning point. We'll be halfway through, so yes. What else do they relate to in terms of the equation? Thinking we're going backwards, so we've got x squared plus blah blah blah. What do we do to find those x-intercepts? Do we factorise first?
Yep.
We do, and then we use the null factor law. Yep. And then what do we get? We get our x-intercepts. So here we've got x equals 1 and x equals 5. So if we're going back the other way, x take 1 and x take 5. And they would be our factors of...
Null factor law.
Yeah, going backwards, yeah. So these two would be these factors in here which come from there. So when we've got our x-intercepts, what do we get from that? They lead us to our factors. So we take 1, so it equals 0, null factor law in reverse. We get our factors. So now we know x minus 1, x minus 5 are our factors. Now what else could there be with this parabola? So here's another parabola that has the same dilation. Alright, so it could be a dilation, couldn't there? So I'm just going to put an A here, it says that could be our dilation. Now what am I going to use to find my dilation? We've used this one, we've used this one to get these. So what's the actual coordinate of that point? What's the x value?
0 and 10.
0 and 10. So if we use 0 and 10, we then get that 10 equals A times 0 minus 1, 0 minus 5, A times negative 1 times negative 5, which is, how many A's?
1. 5.
5. Negative 1 times negative 5 is positive 5 times the A. So what's the A then?
2.
A is 2, so we do have a dilation. So just put it out the front. X minus 1, X minus 5. You can leave it like that if you like. Alright. Anything else in that? Okay, so intercepts, if we've got x-intercepts, they're going to help us find factors. Okay. So in this case we had x equals 1 and x equals 5. Take 1 from both sides. X minus 1 equals 0. X minus 5 equals 0. Null factor law in reverse. They leads to our factors x minus 1 and x minus 5. Could be a dilation. We use our other point. To find our dilation, we find it's 2. Yes? Alright, I think we might leave that as that for the moment. 3K. Alright. So in terms of